Okay, so these are some sample problems from IXL for solving systems of equations, and it will have all three methods on there: graphing, elimination, substitution. So the first one here is graphing, and when you're in IXL, you need to click on which one you're going to graph, either the blue or the orange. So I'm going to do the blue first, and that's the first equation up there. So I'm going to highlight it, and orange is the other one. So blue. This is already in slope-intercept form, so I can plot at 0, and it's -3. So that means I come down 3, 1, 2, 3, and to the right 1, or up 3, 1, 2, 3, and to the left 1. And then I'm going to plot some other points here: 1, 2, 3. 1, 1, 2, 3, 1. 1, 2, 3, 1. And so it would look something like that. And then orange is at 2 intercept. This 2, a -2, 1, up to over 1, up to over 1. And then drawing that line. And my line's a little off, but I can see that they intersect at this point right there, which is -2, 6. And you can always test that out. If I put a -2 in for x in the blue, I get 6 for y. If I put -2 in for x in the orange, I get 4 plus 2, which is 6. So it works. Okay? The colors this time are green and blue. Green is the top one, and blue is the bottom one. Okay, so the top one is not in slope-intercept form, so I need to move the x over and then divide everything through by 3. So plotting that starts at 2, down 1 over 3. Oops. Up 1 over 3. Okay, so it looks something like that. Again, my graph is slightly off. And then blue is already in slope-intercept form. It starts at -2. Up 5, 1, 2, 3, 4, 5, 1, 2, 3. Graphing that. Looks something like that. Hopefully in IXL you'll be able to graph a little bit better than I'm graphing. They intersect at that point that I have highlighted, which is -3. X is always first. 1, 2, 3. Test it out. -3 plus 9 is 6. -3 is 5 minus 2 is 3. So that works. Okay, these colors are green and blue. Green, blue. So in the top one, I need to divide everything through by 15. 5 and 15 reduced to 1/3. And 15 divided by 15 is 1. In the bottom one, I just need to move the x over. And this is an x. So plotting this at starting at -1, Now I have a positive slope, up 1 to the right 3, or down 1 to the left 3. And then blue starts at positive 3, and it's 1 and 1. And I can see that they intersect here, which is -6, -3. If I put a -6 in here, I get -30, minus 15 is -45, so that works. Put a -6 in here, I get 6 minus 3, which is 3, so that works. And the last one to graph, move the y to the left, and then for this one, move the x to the right, and then divide by -10. And my two colors are orange and blue. So the orange one, I start at 4, and it's a negative slope, so it has to be downhill. And then blue starts at +2, and it's a negative slope, so down 1 over 2. They intersect right there, which is 4, 0. So if I put a 4 in here, I get -4 plus 4 is 0. Put a 4 in here, I get -20 minus 0 is -20. So that works. Okay, so that was graphing. So now we have substitution. Substitution works very well when one of your equations is already solved for one of the variables. So I can just substitute in 3 for y into the top equation. So x is 5 and y was already defined as 3. The next one, can see that I have a plus 5y and a minus 5y, so that makes it very easy to do substitution when you have a variable that has a negative and a positive coefficient that are the same. And we could just add these together. That goes to 0. And then substitute that into either one of your two equations. I just chose the top one. Subtract 6, y equals 1. So 2, 1. In this next one, they both say y equals. So I can just substitute x plus 10 in for y. I'm going to add x, subtract 10, divide by 2. Now I'm going to substitute that into my top equation. And I get 6 minus 2 is 4. It's a -6, 4. This one, I'm going to multiply everything in the second equation by a -1, because I see that I have a -6x and a -6x, so I have almost the same coefficient. So I can eliminate that by taking that second equation and multiplying through by a negative. Oh, I knew something wasn't quite right there. Put a negative sign in that didn't belong. So you get y equals 10. So I'll substitute that into the top. Subtract 70. You get negative 54, so x equals 9. So it's 9, 10. Okay, the next one. If I look at that top equation, I could multiply it through by 4 or solve for x. Either one will work. I'm going to multiply through by 4. And my bottom one's already so that I can add these. And when I divide by negative 19, I get 5. Then I have x minus 6 times 5 equals negative 20. Add 30 to both sides, and I get 10. And you can always check these. All right, now we get into where you have to multiply both equations. If I take notice here, I'm going to multiply the top by 8 and the bottom by 4 so that I can eliminate my x's. 8 times 6 is 48, 4, 128. You could have eliminated the y's if you wanted instead, but either way, you have to multiply both equations by a number. So adding these, I get 40, and so you get y equals 4. Then substitute that into one of the two original equations. Doesn't matter which one. So you get negative 4x. I'm going to subtract 32. So you get 4 and 4. Okay, I'll do one more here. I'm going to multiply the bottom by negative 2 so that I can eliminate the y's very easily without having to multiply both equations. So you add them, and you get negative 6x equals negative 30, so x equals 5. And I just substitute that into the first equation. Again, it doesn't matter which one you choose. Subtract 40. So you get 5 and 5. 40 minus 30 is 10. And 35 minus 15 is 20.